Hello, everybody. I'm going to start talking about the red team's redesign crane. So, as we can see here, a couple pictures that come in here. In this top left corner, we can see almost like an isometric view of the redesigned crane. Some major key features of this new design crane was meant to, we eliminated the four-wheel base and turned it into a three-wheel base, but it still allows the crane to move in the original standards that it was meant to move in. We also shortened the boom. We eliminated a part there because it will allow for the moment that occurs at the end of the arm to be a lot lessened due to the moment arm being shortened. Therefore, the motor should not have to work as hard to raise up the same amount of weight. Also, we look at an added counterweight can be seen, which I use a wheel, and this is allow for more safety measures and to allow it to safely be able to raise the weight up and not be able to fling over itself. We also were able to eliminate 21 parts from the original design. So this is huge. It's a very big redesign that we were hoping would be a lot more cost efficient. And as we look forward into the next slide here, we're talking about cost and efficiency analysis. On this first graph at the top, we can see it details the change in time that it took for the crane to raise up 8 quarters from, it was a displacement of 0 to 27 centimeters. And each time we raised it to the same height. And with that, we saw that it took almost 30 seconds every time to raise the 8 quarters. Now that is a significant amount of time, and it took a lot longer than the original design. So with this, as we look onto the second graph, we can see that it talks about our work, our output and input work. We can see that's in millijoules. And with that, we can see that the baseline crane was actually a lot more efficient, almost 4% more efficient. And this is mostly due to the elimination of the gears, which we all saw in our original baseline crane design, in the boom, where the motor would turn onto the worm gear, which would then turn some of the larger gears, where we could actually use gears to gain mechanical advantage. So to lift up something a lot heavier without straining the motor as much. Therefore, that is why we see the efficiency as it is. But at the bottom, we can see that we eliminated 21 parts from the original design, and we were able to eliminate 2 parts altogether, which is very nice. And we can see that the cost dropped down roughly about $3.50. So with this, we're going to go into our performance graphs. Our performance graph, our first one is the AA battery. We can see that is a voltage versus time graph. And with that, when you're looking at a voltage versus time graph, you can see that the slope of the line is usually the current, or for this part, it's the discharge current of that AA battery, of a 50 milliamp battery. The second graph that we see come in here is a force versus displacement graph of our redesigned crane. With that, we can see that the area under the curve would be the work that was done by the motor, that was done to raise the quarters up. So we can see that here on the crane, and it's a nice linear line, because each time it roughly raised the quarters up, the exact same displacement in a relatively the same amount of time. So to go overall, to sum up the analysis of our redesigned crane, some advantages of the crane we saw were that we were able to become a lot more part and cost efficient. The design was simplified in that we did not have as many brackets and as many gears, and therefore it would make it simpler to build and or fix, as well as we added a counterweight for safety precautions. So you can see a nice safe crane here. Looks so much similar to the one that we built. And now we look at some disadvantages of the crane, of the redesigned crane, and we notice that it took a lot longer for the boom to raise, and this is due to the reduced mechanical advantage because of the elimination of the gears. The gears allow us to utilize mechanical advantage and allow for the same motor to raise up a lot larger weight. As you can see here, we have a reduced weight limit on the boom due to that, and therefore, if we try and raise something a lot way exceeding the weight limit, see what happens here in the picture. So I just want to thank everybody for listening to this, and I hope you enjoy the rest of the presentation.